Hi everyone, this is Mr. Beckstrom, and today I'd like to go over finding the turning points of a polynomial function on the graph. So let's first start off with the function. The function here is x cubed minus 5x squared plus 3x minus 2. And the first piece of information I generally like to know is what are the maximum number of turning points? Well, a turning point is where you have a local maximum or a local minimum. So it's when the function goes from increasing to decreasing, or it goes from decreasing to increasing. Well, the maximum number of turning points that a polynomial function can have is one less than the degree of that polynomial. Remember, the degree is the highest exponent in that equation. So here the highest exponent is 3. So this is a third degree polynomial. And the number of turning points is going to be one less than the degree, the maximum number of turning points. So here, 3 minus 1 is going to be 2. So this can have up to 2 different turning points. It doesn't have to have 2, but it can't have more than 2. All right, next thing I want to do is I want to do zoom 6, which is zoom standard. I want to take a look at it and see if I can locate those 2 turning points. Well, here's one where this local maximum is. It's kind of like the vertex of this area, if you want to look at it like that. And then there's one that looks like it's going to be right down here. It's just out of my field of view. And notice this is going towards the negative y values. So I can just adjust my window to hopefully capture that local minimum. So I'm going to hit window. I'm going to go to my y minimum value and make that smaller. So let's go like negative 13 and see. I was at negative 10. I went to negative 13. Let's see if that will show that minimum value there. And it sure does. So that's going to be kind of like if you think of it as a vertex of this little area right here. So now that I can see both of them, and I know that there are not any more because we have a theorem that states that the maximum number of turning points is one less than degree of our polynomial. So let's find the one on the left here first. And I'm going to use second trace, which is our calculate menu. I'm going to go to the maximum function here. And it says, give me a left bound. So remember, I just want to kind of put this maximum between 2 vertical lines. So the first one, I want to make a left vertical line. I hit enter. I want to make a right vertical line, enter. And I want to make sure that the point I'm trying to find is going to be the highest point between these 2 lines, which it is. There's no other point on the graph that's higher between those lines. Now, if I had made my right bound way over here, then it would have given me a point higher than this peak right here. So be careful, just make sure that the vertical lines just have the high point that you're looking for. All right, so guess, no, just enter again, and it tells me that it is 0.33333, which I'm assuming is going to be 1/3. And then we also have, for the y value, negative 1.158519, which is an approximation, which is probably a square root answer. But these calculators do not give answers in square roots, so if we were using these calculators, we could only give an approximation for what I assume to be a radical there. Now, if we want to find this other turning point, which is the local minimum, I'm going to go back to second trace. I'm going to go to minimum, and then I am going to go do a left bound. So pick a point on that graph that is somewhere to the left of that minimum value we're trying to find, somewhere on the right. So I have that minimum between those 2 vertical lines. Hit enter again, and looks like this is going to be at 3, negative 11. 3, negative 11. Now you might say, what is this 2, 9 way down here? Well, this is because, again, these calculators are using 40-year-old technology to solve these problems, and there are going to be some slight errors in the solutions. So we can usually tell what the number is from the first 4 or 5 places after the decimal place. After that, there's going to be small adding, subtracting, multiplying errors that the calculator has. But I hope this helped. If you have any questions, please let me know, and I hope you have a great rest of your day.